We're going to be taking a look at variables in JavaScript. We have used variables throughout the course. We're going to look at them in a bit more detail. First of all, what is a variable? We're provided with an example on the MDN web docs. So the idea here is that we have a HTML button. It's given an ID so we can connect to it with the JavaScript. For example, we have button A. This is an example of a constant variable, by the way. Const button A equals document.querySelector. It's selecting the element with the ID of button underscore A, which is a HTML button. We also see a second example of a variable both declared and initialized. So there's two steps. First of all, the variable is declared, and you don't have to initialize the variable at the same time. You could just write let count followed by a semicolon. So that's declaring the variable. And if we assign it a value at the same time we declare it, it's referred to as initializing the variable, also referred to as defining the variable. Defining and initializing, really the same thing. It's just that you can define and redefine a variable. So it's referred to as initializing when it's the first time the variable is defined. So we have declaring, specifying that the variable should exist, defining, assigning a value to that variable. The key idea is that we now have a JavaScript variable with the value 1. We then add an event listener to button A, that's the HTML button, and the event listener has the following logic. Button A.textContent equals try again. This is after we click. So you can see after we've clicked the button, the text changes to try again. We then have heading A.textContent. The heading is beneath the button, by the way. If you take a look at the original HTML, we also have a H3 tag with the ID heading A. So that's going to be set to count clicks so far. Notice this is a JavaScript string literal made with backticks. We then have a $sign and two curly brackets. Inside the curly brackets, JavaScript is expecting a variable. So we pass the variable count. It's going to be transformed into the string count clicks so far. So in this case, we have 1 click so far. Then at the end of the logic, we have this line count, referring to the variable, plus equals 1. This is a very useful JavaScript shorthand. It's syntactically equivalent to count equals count plus 1. But rather than reference count twice, we can simply write count plus equals 1. So it increments the value of the count variable by 1. So at this stage, the value of the count variable is actually 2. And if we were to click the button again, it's actually going to update the string with the updated variable. So you can see we're storing the value of the number of clicks in that count variable. And every time we click the try again button, the count variable is incremented by 1. Now, why do we need variables? The exercise it poses is try to imagine you had to code this functionality, but you're not allowed to use variables. You have a little bit of a problem because you have to hard code the strings. If we've hard coded that string 1 click so far, well, we don't have a variable that can increment. The string is just going to stay the same at 1 click so far every time we click the button. So we learned that we need variables in JavaScript. Programming doesn't really work without variables. Now you get the idea that a variable is something that holds a value, and very often if you're teaching this concept to a beginner, you'll probably use the illustration of a box. A variable is a box that stores a certain value. So in our previous example, the box is named count, and inside it holds an integer. But variables don't only hold integers. For example, they could hold a string in the case of Bob. It could hold a Boolean, so that's a true or false value. And as we've seen, it can also hold an integer. Now, we've just been given 3 examples of values that could be stored inside a JavaScript variable, but it's not an exhaustive list. For example, we can also store JavaScript objects in a variable. We can store arrays, functions. We can even store some unique values such as null and undefined, more on undefined a bit later, and also symbols. So now let's think about how we declare a variable in JavaScript. We've already seen this in practice. We type the keyword let followed by the name of the variable. For example, let my name is declaring the variable my name, but as we can see, it's not defining a value. It's not initializing the variable. Here's another example, let my age. Now it goes on to say that because they've been declared but not initialized, they currently have no value. They're basically an empty box. And they're assigned a specific value. They have a value of undefined. So if they're declared but not initialized, they have the value undefined. And it mentions that we can check whether these values now exist in the execution environment. So what does that really mean? One of the simple ways that we can initialize an execution environment on Windows, you can just hit Control-Shift and I to open the DevTools, similar shortcuts for other operating systems. And if we head to the console, we actually have a JavaScript execution environment. So we can actually start defining variables here. So let's create the same variable, let my name. So now that variable has been declared, but it's undefined at the moment, if we type my name, we can see it mirrors back to us that the value of this particular variable is undefined. Now let's try typing the variable that doesn't exist. We now get a reference error, my age is not defined. Now this is an interesting error because actually the problem is that the variable's not declared. So this could seem confusing at first. We have a variable that hasn't even been declared, but we get the error message not defined. So what this really means in this context is it hasn't been declared yet, because if the value is undefined, we just get the value reflected back at us. So this particular reference error, my age is not defined, really means my age has not yet been declared. JavaScript doesn't really differentiate. What it's saying is it's looked for that value and it's not getting any results back. Therefore, it's not defined. Whereas in the first case with my name, we actually do have a value, and that is a JavaScript specific value, undefined. The MDN web docs then talk about initializing a variable. We've already discussed that. So this is assuming we've already declared the variable. We don't need to reuse let. We just have my name equals Chris. So if it already has a definition, we're just reassigning that definition. However, if the variable has not been declared yet, then you will need to use let if you want to declare and initialize in a single line. So here's an example of declaration and initialization in the same line, let my dog equals Rover. Now we'll get into some of the slightly more technical aspects of using variables in JavaScript. If you've looked at JavaScript code before, you will see this var keyword, which is also used for declaring variables. So we could have let my name, or we could have var my name. And MDN WebDocs explains that when JavaScript was first created, this was the only way to declare variables. You use the var keyword, but the design of var is confusing and error prone. We'll see an example of that a little bit later. So instead, let was created in the modern versions of JavaScript, a new keyword for creating variables that work somewhat differently to var, fixing its issues in the process. So let's think about a couple of differences between let and var, because you will still see var used in JavaScript code, especially if it's older code. So one difference is that var makes use of something referred to as hoisting. For example, if you take a look at this particular snippet of JavaScript, we have my name equals Chris. Now that could actually create a problem because we're initializing a variable without declaring it first. So you might imagine we're going to get some kind of error. If we take a look at the bottom of the script, we can see that the variable is actually declared at the bottom of the script. So it's actually being defined before it's being declared. Now that actually works with var. It doesn't work with let. It works with var as a result of something that's referred to as hoisting. The idea is that the browser is going to look at this script and it's going to extract any variable declarations made using var and essentially put them at the top of the script. So this is more or less syntactically equivalent to placing var my name at the top of the script. So even though we're only declaring it at the bottom of the script, this particular piece of code is going to work because by the time we set my name equals Chris, the variable has already been declared as a result of hoisting. If you try the same thing with let, it's going to provoke an error because this particular variable hasn't been declared yet, so it can't be defined. Second difference is with var, you can actually redeclare a variable. So we can declare my name and initialize it to Chris. We can then redeclare my name and initialize it to Bob. But if you try doing that with let, it's going to produce an error. We can't use let again on my name because my name's already been declared. We can't declare it a second time using let. The way we do this with let is we first of all declare and initialize. Then if we want to redefine the variable, we simply use my name equals Bob without using let keyword again. Let's now take a look at a final example of the differences between var and let. var is function scoped, whereas let is block scoped. And this can sometimes result in some surprising behaviors that maybe the developer wasn't expecting. Another one of the reasons why let was introduced. And really, it's the correct thing to use in JavaScript code. In other words, there isn't really a situation where you're going to choose to use var instead of let. It still works. It can still sometimes be interesting for historical reasons to compare the difference. But if you are a new JavaScript developer, you should just be using let, and you should also be using const as we're going to explain, but you should not be using var. It's also good just to know how it works in case you're looking at some legacy code. So what's the difference between function and block scoped? Well, imagine we had something like a for loop. In other words, it's going to loop over the code within the block repeatedly. So because var is function scoped, it means the same variable is going to apply to all of the different blocks, because that variable is going to persist across the entire function. Whereas if you're using let, which is block scoped, and we're iterating over the code within blocks 3 times, each of those blocks is going to have its own version of the variable. Just to give you a very rough idea of what this code does, it initializes a variable I using var for the first block, sets it at 0, runs through the block of code, iterates the value of the variable by 1, and keeps doing that so long as the variable is less than 3. So it's going to run the code with the variable equaling 0, 1, and 2. And that's going to happen in both cases. The only difference is that in the second example, we're defining the variable with let. Now, when we take a look at the code itself, it's actually just going to console log or print to the screen the value of the variable. But specifically, it's going to do that after 1 second. It's going to delay execution of this function for 1 second. In other words, by the time we're actually printing the output to the screen, all of the code will already have been run. So we run this block once with the variable equaling 0, then 1, then 2. We would expect the output to be 0, 1, 2. And that's what we get in the case of the second script when we're making use of let. That's because the value of j, or the variable, is block scoped. So we run through the first time, console log j, it's going to be 0, and it's always going to stay 0 for that specific block. It's never going to change. We run again with j equals 1, so that's the second block. It's always going to stay j equals 1. Now contrast that to var, which is function scoped. By the time console.log is actually being called after 1 second, the value of I already equals 3. And that's because the code has completed, it's run through the 3 loops, and the value of I has been incremented until it reaches 3. Because it's function scoped, it means the value of I is going to be constant for all 3 loops. It's already reached the value of 3, so it ends up console logging 333 to the page because the value of I is already 3. So that's the difference between function scoping and block scoping. So just as proof of concept, let's run this code. First of all, we get 333. That's the function scoped var keyword. Then we get 012. That's the block scoped let keyword. So when var is described as error prone, it's because it often ends up not quite doing what the developer expects it to do. It's actually functioning as it's supposed to, as it's been designed, but the way that let has been designed is a little bit more logical, more likely to do what the developer expects. So for that reason, developers just do not use var in the modern era. Now, the main page does link to some extra pages which are worth checking out. For example, you have the reference on var, which also talks about var hoisting. You then have the reference page on let. Some of it's what we've already just covered right now, but if you want a deeper dive, you can check out the 2 different reference pages on var and let respectively. There are certain best practices to follow for naming variables in JavaScript. So we should stick to 0 to 9, A to Z, so alphanumeric characters. We don't want to use other characters because they can sometimes be hard to understand. Don't use underscores at the start of variable names, although this will work. It's generally reserved for very specific meanings. Don't use numbers at the start of variables. This is actually not allowed and will provoke an error. Safe convention is to use lower camel case. That means if your variable is multiple words, the first word is lowercase. All subsequent words have the first letter capitalized and the remaining letters lowercase. That's referred to as lower camel case. Make variable names intuitive. The best variable names are fairly short, but they're still long enough to give a very strong indicator of the value which they contain. So you don't really want variables like X or a variable like Y. Sometimes we see that in examples when we're trying out scripts, but what does X contain? We have no idea in most cases. So we've seen a couple of variables already like my age or my name. They're a little bit longer than they could be. We could just refer to them as X and Y, but they give some information about what the variable contains. This is very useful for later readability. When you're actually programming, you kind of know what your variables are. If I have a variable called XYZ, I'll know what that is. The problem is when I come back in a year's time or when another developer starts looking at the code and they see this variable XYZ being referenced, they're not really going to have any idea what it is. They then have to start tracing that back in the code to see where it was defined and what it does. Whereas if it has a descriptive name, perhaps using lower camel case, you don't need to do that. You can see immediately what the variable is supposed to hold. So we want an intuitive name for our variables. There is, of course, a limit. We do want to be concise. It's finding that nice balance between being concise and descriptive, but you also don't want your variables to be 100 characters long. Variables are case sensitive, so my age or lowercase is different from my age in lower camel case format. And also there are some words that you need to avoid using because they're JavaScript reserved words. So you can't have a variable with the name var. You can't say var equals 1 or var function equals 1 or let equals 1. So you can't name your variables using certain JavaScript reserved keywords. If you want to see all of the keywords, you can head to this lexical grammar article and you can see a list of all of the reserved words. So you can't actually name a variable from any of the keywords in this list. We have some good name examples and some bad name examples. So let's just take a look at a couple. These are fairly good because they're descriptive. Initial color probably contains a color, right? And it's probably the initial color. Final output value, audio 1, audio 2. These might not be the best names for variables. I couldn't tell you exactly what they contain, but they at least give you a fairly good clue of what type of information is being stored in the variable. We then have some bad examples. We have really long variable name. We have a gibberish variable name. That's just going to be ridiculous to type without some kind of autocomplete. So don't do that. You're going to make errors in your code. We have some examples of reserved values that you're not going to be able to use. We then have issues with casing. Your JavaScript will still work. If all of your JavaScript variables are 100% capital letters, it's still going to work. It's not going to be that bad, but there are also accepted conventions just to make your code look a bit tidier. If you're ever showing your code to prospective hirers, for example, it's probably good if you've observed at least a decent number of the commonly accepted conventions. So maybe making use of the lower camel case rather than capital my age. But functionally, your code's still going to work and the naming is still intuitive. So it's really not that bad. We then have a list of the different types we can store in JavaScript. We've touched on this already. So numbers, strings, booleans, arrays, objects. Now, when we're declaring variables in some languages, we actually have to specify what type of data it is. So we can't just provide a string to a variable. We actually have to say, this information that I'm giving you is a string, or this information I'm giving you is an integer. You actually have to tell the programming language what the type of data that's being stored is. With JavaScript, you don't have to do that. It intelligently decides what type of data is being stored. This is something that's referred to as dynamic typing. Without any kind of coding background or context here, when you hear the term a dynamically typed language, it sounds as if someone's doing something very impressive with the keyboard. But it's not referring to typing on a keyboard, it's referring to the types of data being stored. Dynamic typing means it dynamically ascertains the data that you're storing. You may have heard of a version of JavaScript that is not dynamically typed, and it's referred to as TypeScript. Very similar to JavaScript, but it requires you to specify the type of data that's being stored. It's generally considered safer when a language is statically typed, so we have to specify the type of data that's being stored because there's less room for misinterpretation. For example, you provide an integer, but the programming language thinks it's a string because of the way in which you provided it. So sometimes you could have a script that's relying on an integer but ends up getting a string or vice versa, and it could result in an error. Whereas with a statically typed language, you define what the type of data being stored is early on. That way there's no room for misinterpretation. So an example of dynamically typed let my string equals hello. Simple reason the browser is going to treat this as a string is it's in between double quotes. So that's a fairly logical guess that this is supposed to be a string. We don't have to explicitly tell the browser this is a string we're providing to be stored in this variable. If you're using something like TypeScript, then you actually specify that this is a string, by the way, just in case you didn't know. If you were to set the variable my number to 500, well, what type of data is that? Now, in this case, it's a string. Why is it a string? It's a string because it's in between double quotes, but maybe in our mind, we're thinking this was supposed to be a number, and it's actually a string. Maybe later on in our code, we try and add it to another number. It's not going to work as we think it does because this isn't a number. It's not the number 500, it's the string. What may happen here is JavaScript's going to look at the value you try and add and say, well, the first value is a string, so this second value, let's treat that as a string as well. You know what, let's even do that for a bit of fun. Let num1 equals 500, that's a string. Let num2 equals 80, that's clearly an integer. Console.log num1 plus num2. You know, some languages have a difference between the arithmetic addition operator and the concatenation operator, which adds two strings together. JavaScript doesn't have that. Plus is addition, and it's also concatenation. So we're asking JavaScript to add a string to an integer. Now, some languages could error out at this stage and say, you can't add a string to an integer. Here's an error. JavaScript's not going to do that. It's a dynamically typed language. It's going to look at this and say, well, num1 is a string, and you're trying to add something to num1. Num2 must be a string as well. So you may be thinking that you're going to get 580 because 500 plus 80 is 580. Take a look at the output of this script. 580. It's just appended the second number to the first number because it's treating it like a string. If you then try to convert this string later on into an integer and use it as part of a mathematical calculation, well, you just have the wrong number here. You have 50,080. Whereas really, if we were adding the two integers, it would be 580. All of a sudden, you've introduced a bug into your code as a result of dynamic typing. Now, of course, the advantage of dynamic typing is it's very convenient. We don't have to add a bunch of additional words to specify data types. So if I'm honest, I definitely prefer JavaScript to TypeScript, but you have to be a bit more careful to make sure the type of data is as you think it is. And that's something you can check as you go. You can make use of the JavaScript type of operator, and it's going to tell you whether a certain variable is a string or an integer, etc. Now let's take a look at constants in JavaScript. They're really very similar to let with a couple of key differences. So let declares a variable that ultimately may go on to change its value. Const is for creating variables that don't change. There's also a couple of other differences as well. For example, with let, we've seen that you can declare a variable without initializing it. With const, you have to initialize the constant variable at the time of declaration. So if you were to make use of const count, you're going to get an error message. Now we know with let, we can redefine the value of the variable. So we can do something like let count equals 1. So we've initialized the value to 1. We've then redefined it to 2. We don't use let again. We simply write count equals 2. Let's see what happens if we try and do the same with const. Const count equals 1, so we've initialized to 1. Let's now try and change the value to 2. We get an error. You can't do that. It's a constant variable. Now, it doesn't mean we can't change anything at all. So it reads, note that although a constant in JavaScript must always name the same value, you can change the content of the value that it names. This isn't a useful distinction for simple types like numbers or booleans, but consider an object. So simple example, we have const bird. So we're actually going to be initializing this constant as a JavaScript object. It's only going to have one key value pair. It's going to have the key species and the value, which is a string kestrel. So notice it says here you can update, add, or remove properties of an object declared using const, because even though the content of the object has changed, the constant is still pointing to the same object. So an example here, we can set bird.species equals, followed by a new string. Now, if we console log bird.species, we can see it's updated. So this is a const. As long as we don't try and swap the object out with a string or an array, so long as we leave that object there, we can actually add, update, or remove properties on the object. Now, perhaps a developer would look at this and say, well, const versus let, I can do more stuff with let. It's more flexible. So why would I use const? And it's really to do with writing clear and perhaps a little bit safer code. That's the only advantage, really. The MDN web docs reads, if you use const to name a value, it tells anyone looking at your code that this name will never be assigned to a different value. So it's great when you're revisiting your own code or when other developers are looking at your code. It signals intention. It signals that this is going to remain constant throughout the code. And now anytime they see this name later on in the script, they know what it refers to. They know that you haven't redefined it or repurposed it at any point because initially you declared it and defined it as a constant variable. So your intention is for it not to change, and it actually can't change. JavaScript won't allow that value to change. So without looking at the rest of the code, you know that it's still going to be containing the same type of value. It then recommends the following principle for when to use let and when to use const. Use const when you can and use let when you have to. In other words, try and use const. If you just want a single value to be held in a certain variable, then just use const. Whereas if you need it to be updated, so you have to use let, then use let, but use const if you can. So if you can initialize a variable when you declare it, remember that's a requirement for using const, and don't need to reassign it later, make it a constant. So that's pretty much it for this discussion on variables in JavaScript. There's also a link at the bottom of the MDN web docs to this section, Test Your Skills Variables. And it gives you an opportunity to test out some of the code and solve some certain challenges. So maybe take a look at that if you want to fine-tune your skills. Aside from that, look forward to catching you guys in the next part of the course, where we're going to look at numbers and operators in JavaScript.